Okay guys, hello. Grade 9s, yeah, I think it's to use the natural light today. So grade 9s, I hope you're well, I hope you're good. Guys, there is a playlist that I've started for grade 9s for mathematics, okay? For the grade 9 GEC paper that you guys are going to be writing in the next few weeks or so. So please make it a point that you do check out the live lesson after it is done. Yeah, because you get a chance to go over what I went through today. So let's just see today. The plan is to kind of do some aspects today of geometry with the GEC, but to continue on from where basically we had been. So all right, so we had done question 38, 39, and I think we had done 40 as well. So on the screen, right, the live lesson, the last live lesson I did on the playlist on my YouTube channel for the GEC 2022 paper. I think we now have 5 videos, in fact 6 videos in that playlist that basically comprise questions 1 to 10. I think that's video 1, and then questions 11 to 20, and so it goes up until question number 40. Okay, so if we look at question number 40 specifically, they are asking there, what is the rule which maps k, 2 and 5 to become the image of k, which is then k, the complement of it, which is minus 2 and 5. So then the question is, what is the rule which has been applied? Is it A, has there been a reflection in the y-axis in that the x value changed but the y value stayed the same? Or is it B, we subtracted 2, in other words, there's been a translation to the left by 2 units with y staying the same? Or is it C, the point has been translated horizontally 2 units to the right and then y stays the same? Or is it D, x stayed the same whilst y changed, meaning there's a reflection in the x-axis? So which one is it? Is it A, B, C, or D, number 40? So when you look at k, which is 2 and 5, and you look at the change that has happened, the transformation that happened, if you look at the image, right, k that has changed, the x value is now minus 2, whereas it was initially 2, and then the y value is 5. So initially it was 5, it has still remained as 5. So that means if we look at the appropriate rule that has been applied, it has to be A, all right? Where the x value was x, the x value was 2, it changed to become minus 2. So that means we can safely say that it is the rule A that has been applied. And that is as straightforward as it gets with number 40. Okay. Yes, it's grade 9, guys. Let's move on to question number 41. Question number 41 says, which statement describes the transformation of line segment AB? Now guys, I want you to look at line segment AB. Line segment AB is in the third quadrant. Okay, so what's important here is to actually write down what we see with line segment A. So hopefully you can see it there, and I just want to write here at the top. So what we have there is A, all right? And if we read the coordinates of A from the diagram that we see, okay? If we read the coordinates of A from the diagram that we see, okay, yeah, the coordinates of A, there the coordinates of A are. I'm sure you guys can see that X is -4. Okay, because on the x-axis, X is -4 for A. And then Y is -2. All right, that is the point A, read from the Cartesian plane. Let us go look at B, which is in the third quadrant. The point B, you can see that the X value for point B is -1, whereas the Y value is -4. So B is, the X value is -1, whilst the Y value is -4. Now, with that said, we can now see from the line segment where AB is now changed, there's been transformation applied. The new coordinates of A, for A that has changed, I'm sure you can see the line segment in quadrant 2. Okay, the coordinates, as you can see them there, the X value is still -4, but then the Y value has changed. It is not -2, it is +3. Okay, let's look at the transformation or the change of the coordinate of B. So B in the third quadrant was -1, X was -1, and Y was -4. The changed coordinates of B are now what? What can you guys see? The X value is still -1, but then the Y value has changed to become what? It has changed to become +1. So there is something then that we need to ask ourselves as per what we see in the options that we are then left to choose. The question is saying, which statement describes the transformation of line segment AB? Given that A changed, the X coordinate is still -4. Okay, the X coordinate for A is -4. The changed coordinate of A, the image of A, is still -4. All right, so the X value does not change. All right, the X value still does not change. Okay, so ZM, you said you just entered. Okay, if you look at the diagram on your screen, okay, the question is saying, which statement describes the transformation of line segment AB? So if you are looking at the line segment AB, you are looking at the line segment that is in the third quadrant. Okay, I just want to also maybe help you guys understand what I mean by this. On a Cartesian plane, you have the Y and the X-axis. This is the first quadrant, second quadrant, third quadrant, and this is the fourth quadrant. Okay, yeah, all right, first quadrant, second quadrant, third quadrant, this is the fourth quadrant. So the line segment that they are asking you to talk about, or they are asking you to basically look at, is the line segment AB, which is in the third quadrant. That is the line segment AB that they are talking about. So which statement describes the transformation? They want you to explain what happened to the line segment that is in the third quadrant now that it has become the line segment in the what? In the second quadrant. Remember, this is the second quadrant, so this is the second quadrant. Now AB is now here. So what we do is we go to the diagram and we try and identify the points of the line segment first in the what? In the third quadrant. So the line segment AB in the third quadrant, if you look at the points specifically, A has the x coordinate of -4. Okay, that's the x value of A. Then the y value of A is a -2. These are the coordinates read from the Cartesian plane. Look at B. B has the x coordinate -1 and it has the y coordinate -4. Now all of a sudden A, if you look at A that has changed in the second quadrant, the x value is still -4, but then the y value now is what? +3. So it is the y value that changes. Secondly, if you look at this particular B coordinate and you look at the changed, the x value is still the same, but the y value what? Changes. Okay? Yeah. But if you look at the y value having changed for A from -3 to -2 to 3, so that tells you that there is no reflection that we are looking at here specifically. We are looking at a translation. And specifically, what kind of translation? It looks like we are talking about a vertical translation. What is a vertical translation? That's when our line segment moves up, meaning we added something to our y value, or we move down, which means we subtracted something from the y value of the point. Okay, so up movement means we added something to the y value. Down movement means we subtracted something from the y value. So we can see that from quadrant 3 to 2, the line segment moved up. The question is, if it moved up, what did we add to the coordinate of A in order for it to now be transformed? Let's look at the y coordinate of A compared to the y coordinate of the changed A. From -2 to 3, how many units did we add to -2 to get 3? From -2, we go up, we get to -1, that's 1 unit. Then we go up again, we get to 0, that's a second unit. Then we go up another unit, that's 1, 3 units. We go up again, that is 4 units, we get to 2, and then we go up again, we get to 3, that's 5 units in total. So we have added 2 minus 2, 5 units to get to 3. Okay, and also let's check at this one. That means if we added 5 here, it must be that we also added 5 units here to get to +1, because -4 plus 5 gives us +1. -2 plus 5 gives us +3. You see? This is very important. So that means if we go now to our options, A, did we translate 5 units up? Yes, A is the correct option. We translated 5 units up. B, did we reflect in the x-axis? No, we didn't. Because remember, reflection in the x-axis means that if the y coordinate was a -2, it should be that the y coordinate of A changed should be +2 when x stays the same, because reflection in the x-axis means y changes, the sign of y changes. So here the sign of y did not change, okay, with its number that is already there. This as -2 should now here become +2 if it was a reflection in the x-axis whilst x stays the same. So this is not reflection in the x-axis, completely out. B is out. Translated 5 units down. No, it can't be translation 5 units down, because AB in the third quadrant moved up to become A and B, the line segment that is changed. Then D, reflection in the y-axis. Reflection in the y-axis means what? Reflection in the y-axis means that x changes, the x coordinate change. And you can see, guys, that -4, the x coordinate is staying the same. -1 and -1, the x coordinate stays the same. So that is not reflection in the y-axis, okay? Okay, so that answers number 41. So number 41, we would comfortably say, because we know we added 5 units to y, then it means that we translated 5 units up. So it will be then easy for us to then choose our option who? Option A as our answer. That's it. Okay, moving really nicely, guys. Now we enter into the world of geometry. Okay, we now enter into the world of geometry. 42. What is the size of angle AEC? What is the size of what? Of angle what? AEC. AEC. So hopefully we still remember how to conventionally name angles using the arms of a certain line segment. Now, the answer: A is at 60, B is at 90, C is at 180, D is at 360 degrees. What is the size of angle AEC? Is it A, 60 degrees, B, 90 degrees, C, 180 degrees, or D, 360 degrees? What is the size of angle AEC? Now, guys, I want to just take this down for a moment. AEC. This is what they mean by angle AEC. You move with the letter A to E to C. Angle AEC is this angle on this side, because we move with the letters AEC. Now CD, guys, is a straight line. AE, because of this block, this square here means 90 degrees, right angled. Okay, we also say AE is perpendicular to what? To ED. AE is perpendicular to ED. So this box here means 90. CD is a straight line. So that therefore means that this angle here is also what? 90 degrees. So if that is 90, that is also 90. Why? Because angles on a straight line, they add up to 180. So if that is 90 degrees, it also stands to reason that that is also 90. Why? Because this is a straight line, and we know that angles on a straight line should add up to 90 degrees. So angle AEC is also equal to what? 90 degrees. So if we go back to our question, what is the size of angle AEC? We can comfortably and confidently say that our angle AEC, we select the letter what? B, because I've worked it out and I've figured it out. So that means B is the answer. B is the answer. Why is B the selected answer? It's because we are told that B is 90 degrees. So that's why we accept B as the answer. Okay, I hope those who are here are really getting it as I am explaining it. Let's move on to the next question. So I hope you can see the diagram, number 43. The question there is saying, what is the size of the angle that is vertically opposite angle EOD? What is the size of the angle that is vertically opposite to angle EOD? A, is it 80 degrees? B, is it 60 degrees? C, is it 50 degrees? Or D, is it 40 degrees? Pajiwan says 80 and Alu says A. So Pajiwan, I'm guessing, is saying 80 because he has worked out the answer. Alu is then giving us the selection of the correct answer after working it out and saying it is A. All right. Right? So there's nothing as good as verifying something the minute we are able to actually find it out. Okay? So I'm just going to, for a moment, let's just roughly sketch this so that on the side we can actually confirm the answer that has been indicated by my fellow young gentlemen in the comment section. Aphile Mvundlela. Okay, so remember what was the question asking us? It was asking us what is the size of the angle that is vertically opposite angle EOD. Guys, when they say angle EOD, angle EOD, let's be very specific. This is E, this is O, okay, represented by the letter O, and that is D. So they are talking about the angle that is what? That is directly or vertically opposite this one. Okay. What is the size of the angle that is vertically opposite to this one? So vertically opposite EOD is angle what? COF. COF. COF is vertically opposite angle EOD. Because remember, for vertically opposite angles to hold, there must be two intersecting lines and they must be two intersecting straight lines. Those lines must be straight, guys. So we say this angle is equal to that angle, and we say that angle is equal to that angle. That is the vertically opposite angles, and we say the vertically opposite angles, when two lines are intersecting, the vertically opposite angles are what? They are equal. So if we are being asked what is the size of the angle that is vertically opposite EOD, then we can see that the size of the angle that is vertically opposite EOD is 80 degrees, no doubt. So it is what? It is 80 degrees. And we would write the reason if, let's say, for instance, they were actually asking us to actually show in a actual paper, we would say vertically vert op angles equal. So we know that our answer has to be A. The size of the angle that is vertically opposite angle EOD is 80 degrees, guys. So our option that we choose is A. The option we select, the option we write down is A, and we've been able to actually confirm it using the diagram that the angle vertically opposite angle EOD is angle COF. Why? Because we know from our knowledge of geometry that when two lines are intersecting, the word intersect means two lines are crossing each other, those two lines are straight, then we know that this angle here is equal to that angle there. All right, and that angle there is equal to that angle there, because in this situation EOD, this line and that line form this angle and that angle that are vertically opposite each other. So the angle that is vertically opposite angle EOD is this one. It is 80 degrees. So that's why we say A, the answer that we select as the correct option is A, 80 degrees. Clear? I hope we are clear there. Let us move on. Now we are here. Question number 44. After answering 43, now we are answering 44. When we look at 44, we have a nice Z sort of like shape, if you can see it very well. AB is parallel to CD. We have parallel lines as well. There's A, okay, there's B there, all right, as you can see, and there's C and D. And they are asking, why is angle C equal to 38 degrees? Now, where is angle C, guys? Okay, there is angle C. They are asking us, why is angle C equal to 38 degrees? And the answer there, A, alternate angles. AB is parallel to CD. B, corresponding angles. AB is parallel to CD. C, supplementary angles. Or is it D, vertically opposite angles? So Ashumile Willie says alternate angles, right? Alu says A. Martineo says A. Poncho says A. Poncho says A as well. Poncho says A. Martineo says A. Alu says A. So it seems like we have triple A. Lower Ocean also says A. Yeah, that was an explosion of thoughts, eh? So yes, guys, yes. A is our correct option, right? So if we have 38 degrees there, and these lines A, B, and C, D are parallel, then from our knowledge of geometry, we know that between parallel lines, there are three relationships that we know. One is our okay, so we usually look at this thing here, fun. Okay, if there are parallel lines, we know that for parallel lines, the F shape speaks about corresponding angles. Okay, and we always indicate those lines that are parallel when we talk about corresponding angles. Corresponding angles are when we have on top of a particular line the angle, and on top of the other parallel line the angle. Top, we say those angles are corresponding. Or we say bottom. Let me just make my F a little bit bigger so that you guys can see what I mean. I mean that if we have parallel lines like this angle on top will be equal to this angle on top, hence I call it top. Those are corresponding angles if the lines are parallel. Or we say bottom of the line, bottom of this line, bottom, the angles are also what? Equal. So those are corresponding angles. It's either top of this parallel line, on top of that parallel line, those are corresponding angles. We are equal. Bottom of this parallel line, we say those angles are also corresponding and they are equal as long as the lines are what? Are parallel. Those are corresponding angles. So if we look at this diagram, we can clearly see that 38 degrees is not a corresponding angles with C. So corresponding angles is definitely out where the situation is concerned. Okay, I hope that makes sense. Brett Spiegel, all the freaking best to you as you write your IEB paper 1 final exam. Please do follow me. Why? Because I would like to get a response as to how the IEB grade 12 paper was. Are you writing a grade 12 paper? Because obviously I'm just doing grade 9 revision here. If you're writing a grade 12 IEB final paper today, everything of the best. I hope you actually show it heaven. It's grade 12. All the best, buddy boy. I hope you really do exceptionally well in that paper. Show it heaven. I'm sure you've prepared quite well and you well within the preparation. Godspeed. All the blessings attend you. Mighty angels be around you in that exam room as you write. Absolutely all the best. Okay. So, like I was saying, guys, bottom corresponding, top corresponding, as long as we are on the same side of this line. Top equal, bottom equal. These are corresponding angles. This situation, this angle and that angle are not corresponding. As you can see, this is like a ZN shape and it's like this angle, and the question is, why is this angle C equal to that angle, which is 38 degrees? So it is not the corresponding angles relationship. Here we have what we know as the U shape or the C shape relationship. This is what we call this angle and that angle. We say are co-interior angles. The co-interior angles are not equal, they are actually supplementary. In other words, these two angles add up to 180 degrees. I usually call them the armpit angles. What do I mean by armpits? You know, this is like I would say this is your one arm, this is your second arm, this is exactly where your armpits rest. That's where it stinks. That's where it stinks. I call them the armpit angles, the co-interior angles. Those two angles, they add up to 180. They are not equal. So if you add this angle and that angle between the two parallel lines, we say that those angles are supplementary. In other words, what does supplementary mean? It means they add up to 180. We say these are co-interior angles. And obviously, if their lines are parallel, we state the lines parallel. AB is parallel to CD when we write the reason. Okay. Then lastly, we have what we call here as, what we call them, guys, these angles. Okay. The N or the Z shape. Ooh, the N or the Z shape. We call these angles, they are also equal. We say they are alternate angles. Whenever we use alternate angles, we make sure to also state the what? The parallel lines. Okay, that angle is equal to that angle for alternate angle. So corresponding angles and alternate angles are equal, but we just need to make sure we know where the angles are situated. Corresponding means bottom of one parallel line is equal to the angle at the bottom of the other parallel line, as long as they are on the same side of what we call the transversal line. This is a transversal line, these are parallel lines. So on the same side of the transversal line, bottom we are equal, top we are equal. Then obviously with the Z and N shape, those two angles are also equal. We call them alternate angles. Come back to the question. Why is angle C equal to 38 degrees? Is it A? Is it B? Is it C? By the way, supplementary angles, guys, for C, those are angles that add up to 180. So C is out. D, is it vertically opposite angles? Guys, vertically opposite angles, I told you, are angles. The X shape, right? These are angles that are formed opposite intersecting lines. So we say that angle is equal to that angle, vertically opposite angles. That angle is equal to that angle. Those are also vertically opposite angles. As long as the lines are straight and intersecting, we say these are angles that are vertically opposite. So C and D are not really the options we choose. B corresponding angles, I just explained to you that corresponding angles means bottom of this parallel line, bottom of that parallel line, bottom, the angles are equal. Top of this parallel line, top of this parallel line, top, the angles are equal. This is what we call corresponding angles. So it can't be option B. So it definitely has to be what? Option A. Alternate angles. AB is parallel to CD. So 100% correct. That is the option that we are going to go for. Moving right along, guys. Number 45. Okay. So you see, guys, with we just work out, we get the option, we choose, we put it aside. Number 45. We have two straight lines, they are intersecting. Okay. We have angle AOC, which is 3x minus 5 degrees. So AOC is written in terms of x. Guys, I want to say this. Angle AOC is written in terms of x. Please forgive me for my squiggly line. Okay, let me just do a bit of justice here, okay? Because you can't forgive me for a squiggly line where I have explicitly said to you that for angles to say they are vertically opposite, it has to be straight lines. So let's not compromise that, okay? Let us not compromise that. So we have, this is something else I want to basically say. Angle AOC, if we write this, angle AOC is equal to 3x minus 5 degrees. Guys, I want to mention that when you say angle AOC is 3x minus 5 degrees, this angle is an angle written in terms of x. We say this is in terms of x. Okay? In terms of x. Remember, guys, when you did algebraic expressions, all right, if you look at 3x minus 5 degrees, we say how many terms are in the expression. If you say 3x minus 5, how many terms are in the expression? How many terms are in this expression? Yes, we say 3x minus 5 degrees, we say there are 2 terms in the expression. And then if you look at your first term, what is unique about your first term? It has a what? A coefficient which is 3, and it has a what? A variable that is x. Your first term has a coefficient that is 3, and it has a variable that is x. What about your second term? Does your second term have a variable? Well, it doesn't. Okay, it is simply a constant. All right. So in other words, when we say angle AOC is in terms of x, it means that one of the terms has a variable that is what? That is x. So when they ask you to write an angle in terms of x, they are simply saying in the answer that you write for that particular angle, there must be a variable of x somewhere in your terms. Okay? Okay, I hope you understand that. Ahlumile Willie, I understand very, very well. Please have a beautiful, write your exam very, very well. What are you writing, by the way, Ahlumile? Thanks for always joining the live. I always see you in the live. No problem. Remember that I do post the video. Okay, there's a playlist that I'm developing of the GEC live lessons that I do in the morning. Please, guys, on the YouTube channel, make sure you do go to my link. The link is in my bio. It's also MATHSISAGAME. Go to the link in my bio, not the WhatsApp link, but the WhatsApp channel link is also helpful because sometimes I post the actual link of the live lesson that I've done. But go and follow or subscribe to my YouTube channel, the second link in my bio, and then please guys, subscribe, hit on the notification bell. When I upload the video, there's a playlist that is there, that is Maths Grade 9 Maths GEC 2022, because this is a 2022 paper that I've started doing a couple of days back from question 1. We are now in question 45. Okay, question 44 actually. So we are doing one question at a time, and I'm trying to unpack how to answer these questions. Of course, with the geometry is not going to be in the GEC paper 1, which I know, for instance, Eastern Cape learners will be writing a paper 1 for GEC, whereas they'll be writing a district paper for paper 2, on the 5th of November. So Eastern Cape learners are writing on the 5th of November paper 2, and then on the 13th of November paper 1 GEC. So what I'm doing is I'm doing a paper that had both paper 1 and paper 2. In 2022 it had both paper 1 and paper 2, so that we can cover the content of basically everything from that paper. Okay, one question at a time. So please make sure you hop on there, subscribe, so that when I do upload, you can watch. Those who have missed all the first few sessions, you can rewatch it at your own time, at your own pace. So anyways guys, angle AOC is in terms of x, so that's 3x minus 5 degrees. Angle DOB, do you see my letter formation here? Angle DOB, or you could say angle BOD. Angle DOB is also in terms of x, it is x plus 25 degrees. Do you see that, guys? So when we say in terms of x, I hope you now understand. We just mean that somewhere in the expression of the angle, there must be a variable x. Okay, so angles can either be written in terms of a variable, or angles can be written as a pure numerical value or number. Okay, let's understand that, so that when we are asked questions, we can answer accordingly. Okay, I hope that makes sense. Now, they are now asking us, what is the size of angle what? Angle AOC. They are asking for the size of angle AOC, which means, in other words, we need to find the actual value, not AOC in terms of x. Had they said to us, what is the value of, what is angle AOC in terms of x, we would have written angle AOC is equal to 3x minus 5 degrees and left it like that. But now they are asking us, what is the size of angle AOC? And as you can see from the options, all those options are numbers. They are numerical angles. They are saying is A 15 degrees, B 25 degrees, C 30 degrees, or is it D 40 degrees? So that's the $1 million question. What is the value of angle AOC? So guys, first things first, what is the relationship that exists between angle AOC and angle DOB? Someone tell me in the comment section. What relationship, first and foremost, exists between angle AOC and angle DOB? What is the relationship that exists between angle AOC and angle DOB? King's Buddha, you are this Buddha king. Vertically opposite angles. Very true. That is the relationship that exists between angle AOC and angle DOB. They are vertically opposite angles. What do we know about vertically opposite angles? They are equal. I and K sold. Very good. They are equal. So then, if that is the case, I can then say 3x minus 5 degrees is equal to x plus what? Plus 25 degrees. I already know, guys, that angle AOC in terms of x, right, is actually equal to 3x minus 5 degrees. I want the value of this angle, so I'm going to come back and get it. But for now, I'm interested in actually finding out what is the actual value of x using my knowledge of angles. So 3x minus 5 degrees is equal to x plus 25 degrees. Reason, vet, op, angles equal. That's what I would write, right? Now, let us do what? Solve for x. We did solve for x in term 2, so it should be very easy. We transpose x to the left-hand side. It joins its like term. It becomes minus x. We take negative 5. We transpose it to its numerical angle to the other side. It becomes positive 5 degrees because it was negative 5. Now it becomes positive 5 on the other side. First step. 3x minus 2x. The addition and subtraction of like terms. When we add and subtract like terms, what do? We keep the variable. And then what do? We add and subtract the what? The coefficient. This is 3. This here is minus. There's a 1 here. Minus 1. So 3 minus 1 is what? It's 2. So guys, when we add and subtract like terms, we keep the variable. We add and subtract the what? The coefficient, the numbers before the variable. So 3 minus what? 1 is 2. So it's 2x on the left. On the right, what's 25 plus 5? It is 30 degrees. Then we want to solve for x. 2 is multiplied to x. So when 2 is multiplied to x and we want x to be alone, 2 is multiplied to x. So what do we do to 2 to get rid of it? We divide by the same 2. If there was a -3, we would divide by -3. Okay, so we divide by 2. But what we do on the left, we do where? On the right. Okay, then the answer is what? X is equal to what? What's 30 divided by 2, guys? 30 divided by 2 is 15 degrees. So that is 15 degrees, right? Then remember, we were being asked what is the value of angle AOC. 3x minus 5 degrees was the value of angle AOC in terms of x. Now we have found the value of x, so we can now substitute what? X is equal to 15 degrees where? Into the angle. So let us go and substitute 3 into 15 minus 5. We use brackets to substitute. Brackets mean something in maths, and that is, they mean multiply. So 3 times 15 is 45. 45 minus 5 is 40 degrees. So that is the actual value of angle AOC. Okay, it is 40 degrees. Do we see the difference? Ripper is saying, Ripper is writing, you're writing now. All the best, Ripper. All the best. All the world's best to you. Hopefully you show it heaven. You show that paper heaven. I believe in you. I believe in you. I don't even know you, but I believe in you. Okay, guys, angle AOC, 40 degrees. See, that was so smooth. We know angle AOC in terms of x is 3x minus 5 degrees, but after finding the value of x using vertically opposite angles, because of the relationship that we saw between 3x minus 5 and x plus 25 degrees, we set up our equation, gave our reason. Very important, guys, in geometry, that when you write your statement, you support it with a beautiful reason, and then you solve for the variable accordingly. When you get the value of x, because they wanted the angle AOC, we then substitute x is 15 degrees in the place of x, and then we solve for the angle. We get that angle AOC is 40 degrees. And our substitution, when we substitute something, guys, especially when x is a variable next to a coefficient, we substitute using brackets, so that we understand that brackets in maths mean what? Multiply. 3 times 15 is 45, minus the 5 is 40 degrees. So it's easy now. We can go choose our option. What is the size of angle AOC? Is it A, 15 degrees? No. B, 25? No. C, 30 degrees? No. D, 40 degrees? Yes. Yebo, yes. Yebo, yes. Yebo, yes. Who's the man? Who's the girl? Who's the gamer? Who's the best? Who's the man? Who's the gamer? Who's the man? You know? Yeah. Abe yo zalango muone, guys, eh? I wonder, panda. Okay, I think, guys, this is as far as I'll be going for today. All right, so yeah, thank you so much for joining the live. Thank you for joining the live. That was nice, short and sweet, brief, straight to the point. Everything of the best. If there are people that are on here that are writing today, everything of the best for the papers that you guys are writing, whether you are writing maths, whether you're writing any other subject. Everything of the best. I hope you really do the best. The really Adav. Wait for what, my leader? What do you want? What does it mean by the size? They want the actual value of the angle AOC, right? So really Adav, right? Okay, we were given a diagram here and they said, what is the size of angle AOC? So in other words, they want to know the numerical size of this angle, the number size of the angle. Okay, currently we are given angle AOC in terms of x. So the angle here, angle AOC, is in terms of x, and by in terms of x I mean, if you look at angle AOC as 3x minus 5 degrees, you are looking at an expression. Okay, we are back in algebra now. You are looking at an expression where the first term has 3 and x. It's 3x, right? Minus 5 degrees. How many terms are in the expression? There are 2 terms. So this angle AOC is in terms of x. Angle DOB is also in terms of x. The expression of the angle at the moment is in terms of x. So the first term is x plus 25 degrees. Angle AOC is 3x minus 5 degrees. So you have your angles at the moment in what? In terms of x. Because sometimes they ask you, give the angle in terms of x. So you need to be able to know how to write an angle in terms of x. Now what do they want? They want the size, the actual size of the angle AOC. So what did we just do? What we just did then is we checked what is the relationship that exists between angle AOC and angle DOB. What is the what? The relationship. Because geometry is all about the relationships that exist between angles. You know, in parallel lines, we have corresponding angle relationships. Top, we are equal. Bottom, we are equal. We have co-interior angle relationships between parallel lines. Armpits, where it stinks, angle, you add them together, you get 180 degrees. We know those angles are supplementary, the U relationship. We have the N relationship for angles that exist in those positions. We call them alternate angles, you know. Then we have fun X, usually they say fun X. You have the vertically opposite angle relationship. This angle is equal to that angle is equal to that angle. You know what I mean? So in other words, I'm asking, what is the relationship that exists between these two angles? We need to ask ourselves that. So we can see that these angles, someone had said in the comment section, these two angles are vertically opposite angles. They fit in the mold of angles that are equal because they are vertically opposite. Vertically opposite angles exist between what? Two straight intersecting lines, two lines that cut or overlap each other. These two angles then are vertically opposite angles. So then what do? We go ahead and we equate those two angles and we write our reason. Then we solve for x. After getting the x value, which is 15 degrees, and I explained, guys, how we solve for x here. 3x minus 5 degrees equal to x plus 25. You transpose the x on the right, on the left, you transpose the minus 5 to the right, and this is what you see. 3x minus x, you have 25 plus 5 on the right side. Then when we add like terms where variables are in the mix, we know that when we add like terms, we keep the variable, we add or subtract the coefficients. 3 minus 1 is 2x, is just there, stays as it is. 25 plus 5 is 30. Then when we are at this stage, 2 is multiplied to x, so we divide by the 2. What we do on the left, we do where? on the right, we also divide by positive 2. If it was negative 2 here, we would divide by negative 2. What we do on the left, we do on the right. But here, what are we doing? We are dividing by 2 on the left. So we also divide by 2 on the right. We get a value of x, which is 15. Now we know what x is. It is 15 degrees. We can go back to our angle AOC, which was in terms of x. Substitute 15 and then get an answer for angle AOC, which is 40 degrees. This is the size of the angle AOC because it is a number that does not have x. Does that make sense, guys? I hope it makes sense now. The really Adav, very happy for you that you could understand. I am not the masterclass teacher. There's only one great masterclass teacher that ever lived, and that is Jesus Christ. Yeah, so he is helping for me, making a person like me that does not really have any reputation in the world to actually be doing something that can help you guys, so that at the end of the day, he can get all the glory. So hopefully you can then do what needs to be done as you prepare, and you write well. Guys, thank you so much. I'll see you again, same time, same place. I'll be here again tomorrow morning, 5:30. Remember, those that miss my live sessions, guys, if you are on your way to school and you missed this, don't worry. You can always go to my YouTube channel there. In my bio, guys, for this channel, if you followed me, please go to my bio. Go and click on the bio. You will see 2 links. One WhatsApp channel link. The WhatsApp channel link is a channel that's just there so that I can post the clickable links for the YouTube videos that I actually upload. Then there's a second link for the YouTube channel. There's a playlist, guys, for these questions that I'm doing in the mornings, every single morning. I've compiled a playlist. There are 6 videos already that are there. This one would be the 7th video that I will add today. Okay. It has all the live sessions that I've done. Question 1 to 10. I think there's a first video which is just question 1 to 10, where I've done questions 1 to 10 with numbers and your ratios, your rate, all those topics that are at the beginning of the year. Then I think video 2 has expressions, okay, for the same question paper. All right. Tomorrow I'll be continuing on from question 46, 47, and we'll go on from there. Otherwise, thank you so much again. Have a wonderful day. Everything of the best. If you're writing maths today, all the best. If you are writing other subjects, everything of the best. To my IEB people, everything of the best. If you're in grade 12 and you'll be writing your first paper today. Thank you. Have a good day. Thank you. Stay blessed. Shosho.